Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
Sushma, yes.
Result of the
Sushma?
division,
Yeah.
it's
10
10
by
by 3.
Yeah. It gives you as 3, right? It gives you as 3.0. See, run as Java application. See now here? 3.0. So here, if at all we go for proper typecasting, so it will act as double value like 10.0 by 3. So it will give you a double constant like 3.33, no problem. Is it clear now? So on. Okay. Any queries here to any of you? Clear everybody? Right. Shraddha, respond me now. Here, can a static method call multiple static methods?
Yes, it can call multiple static methods.
No problem. If a static method is in another class, how to call?
Class name dot the method name.
Very good. And here, do we need to call all the methods from main method directly?
Sorry?
Do we need to call all methods directly from our main method?
No.
We can have a helper method. Example here, we are taking a helper method here. Our helper method is making a call to all the rest of static methods. So simply we are making our main as a simple method. Okay, we are not making it clumsy by writing everything here itself. Okay, we can make use of helper methods and we can simplify the application. Clear now?
Yeah.
Everybody? Right. Now we will see work with recursive method. What is a recursive method? See, till now we have seen a method calling another method, right? If at all a method is calling itself, we call it as a recursive method. If at all a method is calling itself, we call it as a recursive method. What is a recursive method? A method calling itself is what called as a recursive method. We'll see a simple example now. Focus on all of you here. See, it is a separate class here. We are defining a static method now. See, factorial. Written type is here as integer, so it is going to return some integer value. Parameter is only one integer parameter, right? So see now here it is a separate method main belongs to same class, which is also a static method. Here we have taken a local variable f and value is given as 4. And see now here we are displaying now factorial of 4 is factorial of 4. So we are calling a method now factorial. How does it work now? Simply here now. See now here, we are calling main method is calling a method factorial, right? Main method is calling a method factorial, and we are passing value as 4. Is my screen visible to you all, everybody? Some of you respond to please, Sam. Yeah, thank you. See now here main is a method which is calling a method called as factorial, right? So what's the argument we're passing now here? 4. So immediately now in memory we have a method factorial having parameter value as 4. What are we doing now from here? Return 4 into factorial of 3. So we're calling the same method now once again. See, Factorial, we have called a method factorial. Now, factorial is a method which is calling its own method again, which is calling the same method on its own again. Understand? So this time the same method factorial, we are returning we are passing argument as 3. So in memory, one more copy will be there now. Understand? So this time for the same method factorial, parameter is 3. What are we doing now? Return 3 into factorial of 2. So again the same method, one more copy will be there in memory. The same value 2 will be given as a parameter. What are we doing now? Return 2 into factorial of 1. So once again the same method will be called itself by passing argument as 1. What are we doing now? Return 1. So 1 will be given back here, 1 into 2, 2. 2 will be given back here, 2 into 3, 6. 6 will be given back here, 6 into 4, 24. 24 will be given back to our main method. Understand? So in our memory, it contains the same method again for multiple copies. So every time we make a call to method, simply here it contains a separate copy in memory. So for each and every method call, it maintains a separate copy in memory. That's what we are calling as a factory method. Understand? Clear out you all? See now here a static stack. What is stack here? Stack is called as last in first out. See example, what I say no, but CDs we can store all our CDs right into something like this. A stack will be there, right? So simply here, let's say we are inserting some 3 CDs now. CD1, CD2, CD3. Now while we are taking back, what is the first CD we need to take back? CD3, then CD2, then CD1. Because as you're making use of a CD stack here, always it makes your last in, first out. What are the last CD inserted here on the stack? We need to pick up the same CD out from the stack. Yes or no? In the same way here, stack is one of the data structure. Internally it's stored, it will go for make use of a mechanism called as same last in, first out. In short, we call it as LIFO, last in, first out. See here now, first of all here value 4. So it stores value 4. Then we are saying now 4 into 3. So before calling a method factorial, to remember the value, this value 4 will be stored into stack. Now we are calling factorial of 3. It goes in now. Before calling a method factorial of 2, it will to remember this value for next time. It will store this value 3 into stack. Now it calls method factorial of 2. It goes to method factorial of 2. What's happening now here? Return 2 into factorial of 1. Before calling a method factorial of 1, it stored the value 2 into stack. Understand? Now it calls method here. What's happening here? Directly we are calling returning value 1. So the value comes back now. So 1 into 2. How can we get the value 2 now? Come on. It will fetch the value from stack. Last and first out. What are the values inserted at last? The same value we will pick up now. So it gives you return value as 2. So 2 into 1, 2. Returns here now. Now how to get the left side value here? Again it will go to stack and gets 3. So 3 into 2, 6. 6 will be returned here. How to know left side value here? Again go to stack 4. 4 into 6. Return 24. That's the way how it works. Internally it is making use of stack mechanism to store all the values as a part of factorial. To remember all the method calls, to remember the return value. Internally it is making use of stack. Stack is one of the popular data structure we have. Understand? Where you have mechanism as last in, first out. Understand? That's the way how it works. See the example now. See here. Uh, see here. See. First of all, what is the value of f here? 4. So now 4 into, see, factorial of 4. It goes here now. What's happening now here? Value of x is 4. Come on. X value, is it 1? No. X value is 4. So this is false. It comes to else part now. Return 4 into factorial of 4 minus 1. That is 3. So it will store the value of x into stack and goes to factorial of 3. Again it comes here now. One more copy in memory. Now 3 is it equal to 1? False. It comes here. 3. Value 3 will be stored into stack now. Factorial of 3 minus 1. 3 minus 1 is 2. So factorial of 2. Once again we are calling same method now. Is 2 equal to 1? No, false. So it stores value of 2 into stack and calls again the same method now. Factorial of 2 minus 1 is 1. So it comes here now, value as 1. Again, the same method will be called. So the copy will be there into memory again. Is 1 equal to 1? True. It returns you 1. It comes back now. So now 1 into 2, 2. It returns you 2. It comes back now as 2 here. Now here 2 into 3. From where are we getting the value of 3 here? From our stack. From our stack. We have stack, right? So from the stack, we are able to get the variable what we require. Understand? We are making use of stack data structure internally. Understand? So finally it returns you value as 24 to our main method. Return 1 means directly return the value as 1. I will ask you, give me something. So you may give anything. So simply here, here main is here our factorial is a method now, where we are written as integer. So we need to return some integer value. So we are saying here, return integer value as 1. Right? Am I clear, Sam? Right. Yeah, any queries any of you regarding our recursive method? No queries? If any of you have any queries, please ask me. Adya, can you explain me where is your question, please? Adya, which part is not clear? Can you explain, please? Can you ask me clearly so that I can explain you again? Adya, can you explain what is a factor method? Okay. Adya, factor method is a method which calls you the same method again. Adya, can you talk to me, please?
Yes, Prasad.
Yeah. Adya, see, a factor method is a method which calls itself. See, till now in all the examples you have seen a method calling another method, right? Yes or no?
Yes.
Yeah. Same way now, a method calling itself is what called as a recursive method. In all the examples till now we have seen a method calling another method. In the same way here, right now we are seeing a method calling itself is what called as a recursive method. Clear?
Okay.
See now here.
Prasad, I
So
had a
here,
question.
yeah,
See, method calling itself is factorial method, right?
it is called as recursive method.
Recursive method.
Yeah.
Okay. Now, in this example, is, I mean, it can be also an if and else example, right? Like, for example, if x value equals 1, then it's going to continue. Otherwise it's
If x value is 1, let's say
when
return 1. It returns
it's
the
going to
value as 1.
return 1.
So
Otherwise, it's going to
as
continue till
as this
it
condition
returns.
is true, returns you value directly. If this condition is false, it comes to else part. It executes you only one, either if condition or if it is true, it executes you this part. If it is false, it executes you else part. Same like this. If you get tickets for movie, go to a movie else, go to park or somewhere else. Same way, only one. Either this statement or this statement.
So Prasad, in
Yeah.
here, else return x into factorial. This factorial is nothing but the name we are using. That's why
Yes.
it is called.
Yes. Yes.
Okay.
What are the instead of calling some other method now, they're calling the same method again. Factorial is recursive method is a method which calls itself again and again repeatedly.
So that means the
Method,
factorial which you have written here, like return factorial, that is nothing but the method static int method, right?
yeah, it's a
Oh,
method.
okay, got it. Okay.
So here it is method name, okay? Factorial. It is the same method.
So Prasad, return is working here as a boolean, you mean, or
Integer.
for return? I
Yeah,
mean,
return type is integer. So we're saying here, if at all the parameter value is 1, return the value as 1. Else, we're saying now return the parameter value into factorial of parameter value minus 1. If at all here parameter value is 4, we're saying now here factorial of 4 minus 1. What is 4 minus 1? 3. So
3.
it will receive value as 3. Once again, we are calling same method now. Understand?
But Prasad, in if else condition,
Hmm.
how it works? I mean, why we are calling again and again? It is not a for loop or while, right?
Yes.
So is this also the same process of I mean the flow control? How the while and do while or for loop works?
It's not like that. Simply whenever we have to call, whenever we need to execute same set of code again and again, and based upon some return value, so we can call this method. See, we have to call multiple methods, right? A method may have a lot of functionality. Okay, so whenever we have to execute any code repeatedly again and again, the same method, it may have lots of conditions. Understand? A method may have lots of conditions. In our case, we are taking only two conditions here. One is if and another is else. That's nothing else. Whenever we have to whenever we have a lot of code, and whenever we want to perform here, the same code repeatedly again and again, we make use of a recursive function. Okay, it is very quick, very speed, but it requires more memory. Why? Because every time we call the method, internally it requires the same method as one more copy. Understand? So it needs more memory to execute this, but it is very quick execution. Yes, and it also requires memory to store all the stack values. Every time it should store all the values, right? So internally it will make use of our stack values here. Understand? As I have shown you there, internally it will be making use of a stack. So it stores all the values here in stack. Understand? So here, whenever we are calling. See here your diagram here. The same method we are calling here again and again. First time, again second time, again third time, again fourth time. So the same method will be there in memory for 4 copies now. So the same method is there in memory for 4 copies. Understand? And here we are saying now 4 into factorial of 3. Again factorial of 2. Again 1. It returns you 1 now. 1 into 2, 2. Returns you 2. 2 into 3, 6. Returns you 6. 6 into 4, 24. 24 is given back to main method. Any queries here?
You mean the x value has been changing? You mean? I mean we assign as 4, right?
Hmm. It is
4
storing
is
it is storing value of x into value of 4 into stack. Okay. It is storing value of 4 into stack, and it is going to method call.
but how
See,
it
as a
is
control is
going
going
to
to
if else condition? I mean if it is for loop, it will be go increment or do like that, right?
uh,
If else condition, how it is working? I mean,
it's not a loop. It's not a loop. Okay.
yeah.
If else means
But
simply it will check only one time. Okay. It will check only one time. Simply here, see, here if it is true, it executes this. If it is false, it comes here. That's it. Only one time. But here point is, it's not because of if else. Here we are calling the same method again. Understand? As you're calling the same method again the control goes here.
oh, okay, okay.
Okay? And again we're checking condition now. If it is true, it executes this logic. If it is false, it goes to else part and executes the logic which is there in next line. Okay?
Okay.
So Prasad, does it mean that once we use a method in a method like this, it's always going to use the stack theory?
Yes. Yes. If at all we're going to call same method, okay?
Oh, same method, yes. Same method into a method, then it's going to use the stack theory. I mean, whatever you explain now.
Simply to read it, to remember the values, it will make you a stack. To retain the values, it will make you a stack data structure.
Okay.
Okay? Clear now? Right. With this we are done with our static. Welcome. You go for we've seen all the loops, right? We'll see all control statements now. See now here, it's a if example. You see here, if example we have defined main method now. We're taking here variables, right? As we're declaring them variables inside a method scope, we call them as local variables, right? Value of A is 500, value of B is 1000. Now we are taking one more variable big. We're checking now. If A is greater than B, come on, 500, is it greater than 1000? True or false? It is false. What happens now? Control comes to else part. So what's happening here now? Big is equal to B. What is value of B here? 1000. So now variable big will contain value as B. Now we're displaying here at last. So if condition is true, it executes you if part. If it is false, it comes to else part. And however it is, if it is true, it goes to if part. If it is false, it goes to else part, right? However it is, it comes to remaining statements as well. When displaying a big value is so and so. See now, it is showing a big value is 1000. Yeah, we declared here A, B, and big. All these three variables are declared as integers here. All right. So here, whenever we are having, see here, if condition is there now here. Let's say here I'm removing else part here now. Right now else part is no more, right? See now here. So if condition is true, do this, right? If condition is false, don't do anything. If condition is false, do not do anything, no problem. In that case, need not write else part at all. Else part is always optional. You may go for else part or you may not go for else part, no problem at all. Understand? But right now we're displaying value of big here directly. Understand? See now here, save. Come on, is it true or false now? A value is 500. Let's make B value as 10. Come on, A 500. Is 500 greater than 10? True. So now big value becomes as 500 now. It displays the big value as 500. Am I correct now? Right. Same thing now here. Let's make big value as 1000 now. Come on. Now come on. Now is this condition true now? Is 500 greater than 1000 now? False. Now it is false now. What is value of big now? Here initially we have given big value as 0. So now as it contains 0 and simply now it displays the big value as 0. So save, execute, run as Java program. So now here big value is 0 now. Is it clear? So specification of else method is optional, but it's always a we can use it according to our requirements. Okay, it's optional. If at all we require else part in our programming, we can make use of else part. If it is not required, we need not to use else part. We can ignore it directly. Understand? So now here, coming to our conditions here, we have given a block, right? For if condition we have given one block. For else condition also we have given one block, right? Specifying this block is also optional. Example, see, I am removing this block now. Do I have a block here now? No, there is no block. For else part also I am removing block here. Do I have a block now? No. When do we need to go for block? When it is not required to go for block. Anyway, specifying block is always a good practice, no problem. Inside if condition, if it is true, in our comment if condition, if at all if it is true, we want to execute only one statement, then we can say it as if condition, right? Simply here we can say it as a single statement, right? So if our condition is true, it executes you this single statement. If it is false, it goes to else part and it executes you else part. Understand? That's the way how it works. So simply here it executes either if part or else part. However it is, it works like this. Understand? Say save, right click, run as Java application. Same or not? Right. So as a part of if condition or else part, if at all you have to execute only a single line of code, you may have a block like this or you may not have a block, no problem. So Specifying this block for a single statement is always optional. You may have or you may not have. But if at all you have to execute multiple lines of code in a single block, if at all you have to execute multiple lines of code if the condition is true. Similarly, if at all you have to execute multiple lines of code where condition is false, in all those cases, it's mandatory we need to have a block of code like this. Understand? In all those cases, it is mandatory we need to have a block like this, maybe for if condition or else. Come on, save it now, right click, run as Java application. See now, p value is 1000 now, big value is 1000. That's the way how it works. Is it clear now, everybody?
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website h2kinfosys.com. On our website h2kinfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.